Every local AI guide skips the question that matters most. How much VRAM do you actually need? That single number decides whether your model runs at 60+ tokens a second or nearly stalls. I tested it myself, then checked it against real benchmarks on 3 more GPUs. Here's what holds up. Here's the rule most guides skip. A model must fit inside your GPU's VRAM, weights, and working memory both, or the overflow spills onto your CPU, which can cut your speed by 5 times. And file size on disk isn't what decides this. Context length, how much conversation the model holds in memory, matters just as much. Quick disclosure, this video makes real performance claims. I tested the card in my own laptop. Everything else here comes from published benchmarks. Sources are on screen. My machine runs an RTX 4070 laptop GPU, 8 GB, about the tightest budget you'll actually buy. Every other figure is cross-checked against a second source, and where sources disagree, I'm showing a range, not a made-up number. Here's what 8 GB does. 3 models, ollama's verbose flag real generation speed. Llama 3.2, 1 billion, 64 tokens a second fully on the GPU. QEncoder 7 billion, 41 tokens a second still comfortably on the GPU. Llama 3.1, 8 billion, same card. It collapsed to under 12 tokens a second. Why? Its default context window needs 23 GB, 3 times what the card has. 74% of the work landed on my CPU. The fix capped the context to 8,000 tokens. Same model, 47 tokens a second, back to 100% GPU. 4 times faster, 1 setting. Context length matters more than almost anything else you'll read about buying a GPU. The lineup budget to used market, every number sourced on screen. RTX 3060, 12 GB, around $330 new as of August 2026. NVIDIA brought it back during a memory shortage. On an 8 billion parameter model, 52 to 65 tokens a second. RTX 4060 Ti, 16 GB, around $420 more VRAM than the 3060, but a narrower memory bus, so it lands lower, 34 to 48 tokens a second. RTX 3090, 24 GB, used only, roughly $1,000 to $1,300. Same model class, 87 to 96 tokens a second, the only card here with room for genuinely large models. Where's the real sweet spot? Starting out, the RTX 3060, 12 GB, around $330 is the honest budget pick. Enough headroom you won't fight context limits. Stretching further and buying used anyway, the RTX 3090 is what local AI communities keep recommending, and the benchmarks back it up. 24 GB for used card money. The 4060 Ti's extra VRAM sounds like the upgrade, but its narrower bus holds it back. More VRAM doesn't automatically mean more speed. Here's the trap. Don't buy a new low VRAM card just because it's new. 8 GB hits the same spill I hit on my own laptop, and no amount of compute fixes a model that doesn't fit in memory. And more VRAM doesn't always win either. The 4060 Ti proves bandwidth matters too. The rule: VRAM first, memory bandwidth second, and never trust a tokens per second number without a named source. The whole comparison, one screen. 8 GB my own laptop, the floor usable but you'll hit the spill. 12 GB on the 3060, the honest starting point. 16 on the 4060 Ti, costs more, isn't automatically faster. 24 on a used 3090, the ceiling most people actually need for local AI in 2026. 3 takeaways. 1. VRAM and context length decide your speed, not file size, not the marketing name. 2. For most people starting out, 12 to 24 GB, new or used, covers real local AI work. 3. Check the source before trusting any tokens per second number, including mine, they're all on screen. Next, N8N for beginners, automate anything for free once your local AI is running. Subscribe so you don't miss it. Own your AI.